Hello everyone. In this video, we'll learn about exercise 2.2 in the chapter Polynomials. As we know, the basic form or the format of a polynomial is ax square plus bx plus c equals 0. Here, a and b are the coefficients of x square and x respectively, and c is the constant term. Now, as we saw in the first exercise, a quadratic equation, that is an equation which has the highest power as 2, will have the maximum of two zeros. It can also have 1 0, or it need not have a 0 at all. But mostly it will have two zeros. And in order to find that, we have a method called splitting the middle term. But before we go into that method, since we will solve this and we will get two values, the two values or the two zeros are called alpha and beta. And how can we verify whether the two zeros that we obtain are right? There is a method for this which is called relationship between zeros and coefficients. We need to know that alpha plus beta, that is the sum of the zeros, is nothing but minus b by a, and the product of the zeros is nothing but c by a. So these two equations are very important in order to verify whether the answers that we are going to solve in the next concept are right or wrong. So when we say alpha plus beta, the two answers that we get, the sum of the zeros. And when we say alpha into beta, we say the product of the zeros. And here, as you can see in the right hand side, this minus a by b, c by a, all those are the coefficients of x square and x and the constant term in the polynomial equation. So now let us learn this with an example. This is type 2 in this chapter. It's 3 star, which means it's very important, and it is important from 3 marks point of view. The first step to do is, when we get a question like this and we have been asked to find the zeros and also verify the relationship between the zeros and the coefficients, that is the question. The very first step is to reorder them if they are not in the right order. That is, first we need to have the x square term, and then we need to write the x term, and then we need to write the constant term. As you can see, we have just written them in the proper order. And then what we need to do is we need to multiply this 6 and 3. We'll be getting minus 18. And then all the possible factors of 18. One is 18 one times, and then 9 two times, 6 three times. So these are all the possible combinations, using which we need to bring the middle term, which is minus 7. This is the procedure. So how can we bring minus 7? The only combination that will give us minus 7 is 9 and 2. If we use plus 9 and minus 2, we'll get plus 7. So we need to use minus 9 and plus 2. This is a very crucial step, because if we take the combination incorrectly, then we will not be able to get the answer. Now, the first term remains the same. This combination has to be written in the middle, which is 6x square minus 9x. We need to put an x and then plus 2x and then minus 3. This method is called splitting the middle term, because we are literally splitting the middle term into two. Like minus 7x has been written as minus 9x plus 2x. Once you write it, please verify whether minus 9 plus 2 will give minus 7. This is very important. Now what we do is, and please note that some people may take 2x minus 9x, which is also the same. The order doesn't matter. Eventually, we'll get the same answer. So now we need to take the first two terms and take the common out. So both the numbers are divisible by 3 table. So therefore, we take 3 as common, and both the numbers have the variable x. So we take x also as common. Now this will be 2x. Only then 3 2 times will be 6, and x into x will give x square. So again, the common out step is extremely important. Minus 3, because only then 3 times 3 will be getting 9. So the common out step is very important. Plus, whatever term is here, we need to repeat, whatever sign. If the third term has a plus, we need to repeat the plus. If the third term has a minus, we need to repeat the minus. And There is no common out in these two terms, which means we'll take 1 as common and then write the same thing that we have written over here. This has to be repeated. Even after repetition, if it doesn't hold good, then there is something that we have done wrong in the procedure. That is, 1 times 2x is 2x, 1 times minus 3 is minus 3. Here it's holding good. Please note that whatever is here has to be here as well. It cannot change. Now, because these two are the same, we will write them once. We will take these two as common out, and whatever is left over here, they should be written separately. That is 3x plus 1 equals 0. Until here, we have already learned the same procedure in grade 9. But in grade 10, what we'll be doing is, we'll be equating these two individually to 0. Like this. We'll be equating these two individually to 0. Now in the next step, we get 2x equals plus 3 and x equals 3 by 2. Here we'll be getting 3x equals minus 1 and x equals minus 1 by 3. So we have got two answers. One is x equals 3 by 2 and the other one is x equals minus 1 by 3. Now here this is alpha and this is beta, or we can take it vice versa as well. So these are the two zeros of the polynomial. And I would like to recall what do we mean by zeros. If we substitute this value 3 by 2 in all the places of x in the question, we'll be getting the answer as 0. That is the reason why we call these two as the zeros of the polynomial. Likewise, it holds good for minus 1 by 3 as well. Now, when it comes to verification, how do we verify whether the answer that we have got is right or wrong? One is, as we saw in the previous concept, alpha plus beta and minus b by a should be the same. Please use this line of separation. Don't let us not put equal to in the very beginning, because we need to prove whether they are equal or not. Now, this is the first step of verification. Alpha is 3 by 2 as we have got, and beta is minus 1 by 3. Now plus into minus becomes minus, and we need to take the LCM over here, times 2 times 3, and then we get 9 minus 2 by 6, which is 7 by 6. Now let us check if we get the same 7 by 6 in the right hand side as well, before which we need to write down the values of a, b and c. As per the question, coefficient of x square is a, which is 6, and coefficient of x is b, which is minus 7, and constant term is c, which is minus 3. When we substitute this, it's very important to remember that there is a minus in the formula itself, and the value of b is minus 7, a is 6. Minus times minus becomes plus, and we get the same 7 by 6 as the solution. This is one verification. We need to do the other verification as well. So the second verification strategy is called product of the zeros, which is alpha times beta should be equal to c by a. The value of alpha is 3 by 2 and value of beta is minus 1 by 3. These two get cancelled and we get minus 1 by 2. The value of c, as per the question, is minus 3 and the value of a is 6. We need to simplify it and then check whether they are equal. Now they are also equal. So this verifies that whatever we have done is absolutely right. So this is how we do, finding the zeros of the polynomial and verifying the relationship. To make concepts much better, let us do one more problem from this, which is 4s square minus 4s plus 1. So when we take the case of 4s square minus 4s plus 1, first step to do is to check whether they are in the order. Of course, they are in the order, so we can just proceed. And we need to multiply this 4 and 1, we get 4. The possible factors are 4 1 times, 2 2 times. We use 2 2 times and then we do this. But we need to do minus 2 in order to get minus 4, the middle term. So now this will become 4s square minus 2s plus 1. We have split the middle term as minus 2s minus 2s. Now when we take the common from the first two terms, we get 2s as common. So we get 2s minus 1. As I told, the third term's sign has to be repeated as such, which means there will be a minus and there is nothing common here, which means we put a 1 and we repeat the same term here as well, which is 2s minus 1. When we cross check, it will hold good. For example, minus 1 times will be my minus 1 times minus 1 will be plus 1. After we do this, the one term that has been repeated, 2s minus 1, that will be taken as common out, and the remaining term is also 2s minus 1, this one, 2s and minus 1, and then we equate it to 0. Now when we separate this, 2s minus 1 equals 0, we get 2s equals 1, s equals 1 by 2, and it is the same here as well. So we get the same answer again, that is s equals 1 by 2. So this is called a double root or a repeated root, which means we're getting the same answer twice, which is basically 1 0 repeated twice, which means, just to recall, when we draw this on the graph, we'll be getting a parabola which touches the x-axis at only one point because we get the same answer twice. Now, coming back to verification, before we verify, it's very important to jot down the values of a, b, and c. As you can see, a value is 4, coefficient of s square. B value is minus 4, which is coefficient of s, and c is constant term. Now, one value is alpha, other value is beta. The zeros that we have got, we tag them as alpha and beta. That is, alpha is 1 by 2, beta is also 1 by 2. Now, when we try to verify them, one of the verification is alpha plus beta should be equal to minus b by a. Alpha is nothing but 1 by 2. Beta is also 1 by 2. When we add both of these, we get 1. And minus b by a, the value of b is minus 4 and a is 4. So this will also give us 1. So this is the verification. And we can also verify whether alpha beta equals c by a. That can also be done. Alpha is 1 by 2, beta is 1 by 2. When we multiply, we get 1 by 4. And the value of c is 1, a is 4, which is also 1 by 4. So this is the verification. So with these two problems, I hope you're able to get how to find the relationship between the zeros and coefficients, and also finding the zeros in the first place. Now it's practice time. Let us try to try these two problems. You can pause and try these problems. Yeah. So some of us might have found these two problems difficult because one of the terms is missing. For example, in the third question, 4u square plus 8u, there is no constant term at all. Likewise, in this term, there is no middle term. That is, the term t is missing. Then how do we do? So when we don't have the constant term, we cannot do splitting the middle term. Rather, we'll use a different strategy. So we'll just take this question, equate it to 0. We'll take common out. In both these, directly we'll take the common out without splitting the middle term. 4u can be taken common. We'll get u plus 2. Now this 4u has to be equated to 0 separately. And this u plus 2 has to be equated to 0 separately. The next step, we get u equals 0 by 4, which is basically 0. And u equals minus 2. So when we have a question where there is no last term or the constant term, we just take common out and we do it like this instead of doing it using the splitting the middle term. So that is the strategy. Let us also learn the verification for this. In this question, as you can see, the value of a is 4 because that's the coefficient of u square. The value of b is 8. Constant term, it's not there, so we take it as 0. And then alpha plus beta should be equal to minus b by a. Alpha, we can take one of the zeros as alpha, other zero as beta. So we'll be getting 0 plus of minus 2, we get minus 2. And then in the formula, there is minus 8 by 4, which is also minus 2. The next verification is alpha beta, whether it is equal to c by a. The value of alpha is 0, the value of beta is -2. So this will become 0, and the value of C is 0, and A is 4. Everything is mentioned, so this is also 0. This is the verification for this particular problem. Let us also try to learn the next question. I'll be erasing a few parts of the board. Please feel free to pause, rewind, and watch. The next question, as you can see, there is no t term, there is no middle term over here. Then we can do this using two different methods. Let me teach method 1, which is we directly equate this to 0. And we take the -15 to the other side, it becomes +15. Now, when we make t square as t, we take the root on the other side, but we need to mention plus or minus, because plus root 15 times plus root 15 will also give 15. Minus root 15 times minus root 15 will also give 15. So therefore, we have to introduce plus or minus. Here, plus root 15 is alpha and minus root 15 is beta. This is one method of doing this. The method 2 is basically we write this 15 as root 15 square. Any number can be written as root of it, square of it. For example, 2 can be written as root 2 square because square and root will get cancelled. So here in the question, we are able to write the 15 as root 15 square. Now this resembles a square minus b square form, which is basically a plus b times a minus b. So now this becomes t plus root 15. When we apply this formula, it becomes t minus root 15, a plus b into a minus b. Now when we equate these individually, we get minus root 15 or plus root 15. Again, these can be the values of alpha and beta. So between these two methods, you may choose one and you may solve. Both are acceptable. And with respect to the verification for this particular question, let us try to write down the values of a, b, and c. The value of a is 1, t square is coefficient. There is no t term, so 0. Constant term is -15. Now the first verification is alpha plus beta should be equal to minus b by a. Alpha is root 15 plus beta is minus root 15 plus times minus is minus. So root 15 minus root 15 will become 0. And minus b by a is minus 0 by 1, which is also 0. So this is the verification for sum of the zeros. When it comes to product of the zeros, that is alpha times beta, then let us learn how to do that. So alpha beta, whether it's equal to c by a. Alpha, as you can see, is root 15, beta is minus root 15, plus times minus is minus, root into root, the roots go off and you get 15. C is minus 15 by 1, which is nothing but minus 15. So this is the verification for the fourth sum. Having said all this, now it's practice time. You may try these three sums, what you're getting. You can pause the video and try these three questions. And these are the answers for the three questions. If you have any doubts, please drop it in the comment section. So this is the next concept, that is type 3, and it's of medium importance. As you can see, there are 2 stars and it's a 2 marks question. This is the reverse of type 2, which we just saw, which is basically they would have given the zeros and we need to find the polynomial. So there is a format for this, which is x square minus sum of the zeros times x plus product of the zeros. This is very important. X square minus alpha plus beta times x plus alpha beta. This is the general format that we will be using to solve or to find the quadratic equation if the zeros are given. So basically what I'm trying to say is, in type 2 that we saw here, They will give the polynomial, we need to find the zeros. But in type 3, they will give the zeros, we need to find the polynomial. And this format has to be understood in order to solve these kind of sums. Please note that in this question, we need to find a quadratic polynomial. They have given the sum and product of its zeros, which means this minus 1 by 4 that they've given is the sum of the zeros. That is alpha plus beta. And the second value, 1 by 4 that they have given is the product of the zeros, which is alpha into beta. As you can see from the question, they are the sum and product. We need to directly substitute them in this format, which is x square minus alpha plus beta value is minus 1 by 4 times x, and alpha beta value is 1 by 4. Just substitution. Now we need to take the LCM, before which minus times minus becomes plus, so we'll be getting 1 by 4x, and here also we have 1 by 4. We need to take the LCM, which is 4, so into 4 into 4, we have 4x square plus 1x plus 1 whole divided by 4 equals 0. In the next step, this 4 goes to the other side and becomes 0 by getting multiplied with 0. So we get the final answer as 4x square plus x plus 1. But we need to conclude this by writing the value like this. The expression should be written like this, because only this is not a quadratic equation for which we'll be getting this combination of zeros. Any higher value, for example, even if we multiply this polynomial by 2, for example, 8x square plus 2x plus 2, the whole equation when we multiply it by 2, even for this polynomial, we'll get the same set of zeros. So for any higher value or any multiple of this polynomial, we'll get the same value. So because of which we need to put a k over here and then conclude it in this format. Having said that, it is very important to note whether in the question they have given the sum and product or they have given the zeros. For example, in the question they have not given the sum and product, but they have just mentioned the zeros. For example, 2 and minus 3. We need to add them and find the value of alpha beta. We need to multiply and find the value of alpha beta and then substitute it in this format, rather than substituting them directly like what we have done over here. Because in this question they have given the sum and product, but in another question they may not give the sum and product, rather expect us to do the sum and product and then substitute. So please be take caution while we do such kind of problems. What they have given, what they have asked, all this is very important. And now it's practice time. You can try these two. This is the sum of the zeros, the first values. The second value is product of the zeros. You can try. You can pause the video and try these two. And these are the answers. You may verify. If you have any doubts, please drop it in the comment section. If you have any suggestions as to how differently these videos can be done, or if you have any concept which you want me to explain, please drop it down in the comment section and I will try to put a video for that. Thank you. Thank you for your time.